Hello there, this is Miss Nakayama, and today's lesson is 2.3, Polynomial Functions and Their Graphs. Now, just a heads up, this may be a little bit long. Y'all did all of these little things last year, but you didn't put them together in the graphs. And so that's why I got to go over everything quickly and then show you how it all comes together. So I can't encourage you enough. Take some good notes, write down any questions. If I talk too fast through something or you don't know where something came from, please ask me. Ask me in class, email me, whatever's easiest for you. So what we're going to cover is identifying polynomial functions, recognizing the characteristics, determining their end behavior. We're going to factor to find those zeros. We're going to identify zeros and their multiplicities, use the intermediate value theorem, understand the relationship between degree and turning points, and then finally put it all together by graphing these polynomial functions. So first off, a polynomial is this long, you might think, ugly thing. And I highlight this first one, the first term, a sub n, x sub n, because what matters about that is it is of degree n, okay? A sub n is the actual coefficient of that variable, and if it is the coefficient of the variable to the highest power, it is called the leading coefficient. So as long as your exponents go in order, you just have to look at the first one. This is the leading coefficient. This right here is the degree of your polynomial. Okay? Every polynomial, when you graph it, of degree 2 or higher is always smooth and continuous. And when we say smooth, it's exactly what it means. There are no sharp corners. So that's an example of a polynomial. This would not be a polynomial because we've got some sharp corners in there. Continuous means that you can draw the whole thing, and I've already been talking to y'all about this. Draw the whole thing, start at the left, go all the way to the right arrow, left arrow to right arrow without picking up your pencil. So an example of one that is not continuous would be something like this, which is what we had in our piecewise functions, okay? But everything we're going to be graphing is going to be something like that. It'll be smooth and continuous. Now, you talked about the end behavior of a polynomial. The end behavior, y'all, is referring to those arrows. What are those arrows doing? Okay? So that's the end behavior. And the sign of that leading coefficient that I just talked about and the degree together will tell you what the end behavior is. Okay? So the degree, as I said, is going to be the first one if you write them in order from highest to lowest. So otherwise you got to search out for the highest one. Okay? Now, if it increases, this is talking about any kind of graph, any kind of polynomial that we have. It will increase or decrease without bound. Therefore, it eventually rises or falls. This is according to the leading coefficient test. And here it is summarized for you. Okay, so when you find this leading coefficient, it would really help me for you to circle it so I know you know which one is the highest exponent. And you're looking for n. N as the exponent of x. And if it is odd, then my arrows are going to go in different directions. This is odd positive. That's what that says right here. This is odd negative. And if n is even, then the arrows will go in the same direction. Positive means they both will go up. Negative means they both will go down. Now, I want to tell you what you already know. Okay, odd, y equals x cubed. You know it looks like this. Okay, those arrows go in different directions. Even, y equals x squared. Well, you know what that looks like because we've been talking about it. Those arrows go in the same direction. So if you remember those two graphs, then you will always know when you figure out whether it's odd or even, which way it's going. Okay, it just flips. This is the positive version. It will flip if it's negative. So here's an example of what you got to do. Use the leading coefficient test to determine the end behavior of the graph. So I'm looking for the highest exponent. The highest exponent in this case is a 4, which is an even number. And therefore, it's either going to go up, both of them are going to go up, or both are going to go down. All right, then I'm looking at the coefficient. In this case, it's a 1, which is positive, so I know my end behavior is up and up. Both arrows go up, and there we have it. Okay, next we're going to talk about the zeros of a polynomial. Okay, the zeros of the polynomial are when the polynomial is equal to 0. That's what it says right here. F of x is equal to 0. That's why they're called the zeros. But they're also known as the roots or the solutions of the related equation. Okay? Each real root of the polynomial will be an x-intercept of the graph. Okay, we've kind of talked about that already, but look at this example of what you'll have to do. Find all the zeros of the polynomial function. Okay, and I'm going to go over this in a little bit more detail because several people have trouble factoring by grouping. Okay, so we're setting it equal to 0. But if you've got 4 terms, you're supposed to group the first 2 and the last 2. And when you look at those first 2 terms, what do they have in common? X squared. What's left is x plus 2. And then I tell you, you're always supposed to carry down that sign. A lot of y'all don't write it, and then you mess up the step that comes next. Okay? The other thing that I've told you is after you factor this first one, just write that same factor again. And then think to yourself, well, what do I multiply x by to get 4x? Well, that answer is 4. And then you can check it if you want to. Negative 4 times x, negative 4x. Negative 4 times 2 is negative 8. And a lot of people don't do, they want to write in minus 2 because that's minus. But if you follow those steps like that, you'll still get it right. Okay? My common factor here is an x plus 2, leaving me with x squared minus 4. And that can go further because that's the difference of 2 squares. So that gives us x plus 2, carrying that one down, and x squared minus 4 becomes x plus 2x minus 2. So you want to write that as x plus 2 quantity squared because I have 2 of these factors. So that's why that 2 for an exponent is right there. And then when you set each of those factors equal to 0, you find out that x equals negative 2 or positive 2. So the zeros of my function are negative 2 and positive 2. And if you graphed it to check it, it would look like that. Okay, so you can see that it is, and we're going to talk about why they behave differently in just a second, like right now. Okay, multiplicity and x-intercepts. So when you solve and you factor like we just did, okay, then when you have a 0 that has a multiplicity of k, and all that means, y'all, when they say that, they're asking you what's the exponent on the factor. So that last one that we just did, well, hold on, let me finish talking, and then we'll go back and look at that. Now, if it has an even multiplicity, then the graph will touch the x-axis. Think about x squared. Y equals x squared. It touches the graph right there. If it has an odd multiplicity, then it's going to cross. Think about y equals x cubed, looking like this. Okay, and it crosses at 0. This one touches, okay? This one right here touches, this one crosses, okay? So if you look back, okay, let me finish this, sorry. Regardless of whether the multiplicity of the 0 is even or odd, the graphs tend to flatten if that multiplicity is greater than 1, okay? So if this is a cubed, that would look different than if it was just y equals x, which just goes straight through. So it flattens out a little bit, okay? So if you look back at this problem we just did, x plus 2, which gave me the 0 of negative 2, had an exponent of 2 on it. Well, so it touched at that point. And this factor, which gave us this 0, has an exponent of 1 or a multiplicity of 1, so it just went straight through. It didn't flatten, it didn't touch. So we're going to have to go do that with this graph. Find the zeros of the graph and give the multiplicities of each 0. State whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. Okay, so first off, I'm going to take each factor. Y'all, there is no x here, so you don't have to worry about it. I only have to worry about a factor that has an x in it. So I'm going to take x plus 1/2 and set it equal to 0. X equals negative 1/2. It has an exponent of 2, so we say its multiplicity is 2. And since that's an even number, it's going to touch the x-axis and go back the direction it came. All right. And then the other factor I have is x minus 5. Set it equal to 0. That means x equals 5. The exponent on it is 3, so it has a multiplicity of 3, and this is going to cross. Now, because it's 3 and not 1, it will flatten out a little bit when it crosses, and this is what that graph looks like. Here's negative 1/2 right here. Okay, so you can see that it touched at negative 1/2 and went back in the same direction, and then it flattened out at 5 and kept on going. Okay, something called the intermediate value theorem. Okay, when you have two y values, f of a and f of b, that have opposite signs, then we know that it has to cross the x-axis between a and b. Okay, don't get bogged down by this. Look at what you're going to have to be able to do. Show that the polynomial f of x equals 3x cubed plus minus 10x plus 9 has a real 0 between negative 3 and negative 2. So that means on your paper you need to write, what is f of negative 3? Well, of course, I'm going to go plug in I'm going to plug in negative 3 for x everywhere. And when I do that, I get negative 42. And now I'm going to go find f of negative 2. And f of negative 2 means I'm going to plug negative 2 in for x. This is where your table feature comes in quite handy on the calculator. So plug in negative 2, and when I simplify that, I get 5. So the fact that this is a negative number and this is a positive number means it had to cross the x-axis between those 2 points. Here's our graph, okay? So negative 3 was negative 42. And negative 2 was 5, so it had to cross to be able to connect those 2 points. So I knew there was a 0 between negative 3 and negative 2. That's all the intermediate value theorem says. Okay, another helpful thing when we're graphing is to know the turning points, the peaks and valleys. Okay, in general, okay, if it has a degree, if a polynomial function has a degree of n, then it will have at most n minus 1 turning points. Okay, what was this one? This was a cubic, so it would have at most 3 minus 1, which is 2 turning points. Well, there's a turning point. That's a peak. There's another turning point. Its turning point is just when it changes direction. But you can't have, it's always going to be 1 less than whatever the degree of your polynomial is. Okay, so to graph, these are our steps. Okay, you're going to, and fortunately, MyLab Math will step you through this process, but sometimes you have to do it by hand. So write them down if you can't remember what they are. Okay, you're going to use the leading coefficient test to find the end behavior. Then you're going to find the x-intercepts by setting it equal to 0 and factoring. Think about the multiplicity that I just talked about. Then you're going to find the y-intercept, and then you're going to use symmetry, if applicable, to help draw the graph, and I'm going to talk to you about that. And remember to use the fact of the maximum number of turning points is always n minus 1 to check whether or not you've drawn that graph correctly. Okay, so here's the last example I'm going to do, and then I'm going to do a few problems in MyLab Math just to make it easier for you. So the first step, excuse me, is to do the leading coefficient test. Okay, so I'm looking at this. How many x's do I have here? And the leading coefficient, y'all, this is what all you have to worry about is it's a 2 and then x squared and then x. That's what I'm doing because I only care about the beginning. So 2x squared and x give me a total of 2x cubed. That is odd and it is positive, so I know my arrows are going to go down and up. Okay, next I'm going to go find my x-intercepts. X-intercepts means I have a number for x and y is 0. All right, and fortunately it's already in factored form, so I didn't have to factor it like I did earlier. So I just take each factor and set it equal to 0. X plus 2 is 0, x equals negative 2, What is the exponent on that? It is a 2. So I know my graph is going to touch at that point. Then I have x minus 3 equals 0. So x equals 3. The exponent on it is a 1. So it will just cross, not even flatten out at that point. Okay. Third step, find your y-intercept. That's when x is 0 and y is some number. So I'm calculating f of 0. So I'm going to go plug in 0 wherever I have x. And when I multiply that out, I get negative 24. And then the last thing you have to do is actually go pick some points between the zeros. Okay, these are my zeros, negative 2 and 3. So use that table feature on your graph is the easiest way to do it. So this is what my table looked like. Okay, and when they talked about the odd and even, y'all, remember we've talked about the fact that negative 1 gave us, is negative 8 and 1 is negative 36. Since these two values, y values, are not the same, then I know it's not an odd function, nor is it an even function. Okay, so in that case, there is no symmetry. So that answers that question. And this is the graph all put together. Okay, my arrows down and then up, my x-intercepts, my y-intercepts, and then the other points on my graph from my table. Okay, the last thing I want to do is do some examples in MyLab Math, just so that you don't have any trouble, and it'll be that much easier for you, and you'll see how nice it is to use MyLab Math. So this first example that I have, use the leading coefficient test to determine the end behavior of the graph of the given polynomial function. Okay, so all you have to do, you're given 4 graphs, and here are 4 equations, y'all. So I'm looking at this guy, and the highest exponent's a 4, which means my arrows are going to go the same way. So I only have to worry about this one and this one, 2 and 4. He's got a negative in front. It's got to be going down. Boom. Okay, I had trouble with this before. Seriously? There we go. All right, and so here's another one that's even. This one is odd. We can go here. Odd, it's odd. They're going to go in a different direction, and it's positive. And so positive starts here and goes up. So this has to be my odd positive. Golly. And then this one, x squared. They both go in the same direction. They got to be going up. And that leaves this one here. So that was all that is. All right, now I'm going to step through another graph. Oh, my bad. What do I have to do? I have to check my answer. Okay, good. Now I'm going to go on to number 12. It's going to take me to 7, but I want to go to 12. Same old, same old. All right, number 12. All right, this one, y'all, it's the same kind of factoring that I did on the video, so I'm going to speed through it, and I'm just going to show you how it's working here. Use the lead coefficient, okay? My leading term is odd and positive, so I know it's going to fall on the left and rise to the right. Check. Next, find the x-intercepts. Y'all pay attention. Type an integer or decimal. Use a comma to separate answers. So even though I write them as 0, whatever it is, comma 0, you got to pay attention. Sometimes this program asks you to put the 0 and type it as coordinates, and sometimes it doesn't. But I have done the factoring, so I'm going to go ahead and say it's negative 3, comma negative 1, and 1. Like that. Okay, next I'm going to find the y-intercept. That means I just plug in 0, and if I have it in this form, then that last number without an x is my y-intercept. Oh, wait. Oh, well, my bad. Guess what? I had to find all of them. I have to answer the question. This is why I was showing it to you. At which x-intercept does it cross the x-axis? Okay, all of these have a multiplicity of 1, so they're all going to cross. So that's what I should have put here. So moving on. C. Let's read the question. At which x-intercept does it touch? Okay, there are no x-intercepts because all the ones that I had all crossed. All right, next I'm going to go and answer the y-intercept. Now I'm going to go put that negative 3. They just happen to be the same. Negative 3. And then part D, the symmetry. Remember, I looked at a table, and my table has when I put in a positive and a negative x, I don't get the same y value. So I'm going to say that it has neither symmetry. And now we're going to go graph it. So I'm going to go click on to enlarge. And I'm going to pick the tool. See, this is now we have a polynomial tool. So we had the quadratic, we had the absolute value, and now polynomial more than, it's called a 3-point cubic tool, 4-point cubic tool. Select the graph to plot the first point. Okay, so I had my zeros. I had -3, I had -1, and I had 1. Okay, click the graph to plot the last point. So I need one other one, and the other one that we had was our y-intercept, which was -3. And so, boom, check. And that's what you got to do. So you got to find all those parts to it, okay? The last problem that I wanted to do for y'all was in factored form because people get confused, okay, in this particular problem. So number 12, you had to factor it. This one, it's already in the factored form, which makes it a little bit nice, but it's harder for people to determine the leading coefficient. So if you add up your x's, I have 2 right here, I have 3 in this guy, and I have 1 here. And 2 plus 3 plus 1 is 6. That's an even number. The leading coefficient is positive, so they're both going to go up. So that means the graph rises left and right. Weird wording. Okay. Part B, the x-intercepts. Okay. This first one, y'all, x-intercept is 0. Next one, the x-intercept is 4. And the last one, the x-intercept is -3. Okay. Now we have to say which one does what. At which 0 does the graph cross? Okay. The 0 has an even exponent, so it touches. The 4 has an odd, and the -3 has an odd. So the ones that are going to cross are going to be 4 and -3. And then I'm going to answer which 0 does it touch. That's the other one that I had, which was 0. Excuse me, I don't know why I did that. Okay, and then almost done, hang in there, the y-intercept. Okay, so this one's a little trickier, but that y-intercept, if you put 0 in, this one was easy because 0, 0 is going to be my y-intercept. So we already got that one because I plugged in 0 for everything, and I'm going to get 0. Okay, and then the symmetry, I looked at the table. There is no point that matches, so there's my final check. And now I'm going to put it, now I just got to pick the graph. So I said that my arrows went up and up, so I don't have to worry about this one or this one. Now I have to figure out which of these it is. Okay, so think about your zeros. My zeros were at 4 and -3. So if I click on this button to enlarge it, do I have it at 4 and -3? And that is not the correct graph. So this is the correct graph. And that is all. So there was a lot to that lesson. I hope that y'all wrote down some key concepts to help you remember what those steps are or how to find each of the pieces of those graphs. Thank you so much for watching, and y'all have a great day.